Hello, in this video, I'm going to show you how to segment high-resolution satellite imagery from the Maxar Open Data Program for the Libya floods. First, let me show you where you can get all the resources. During the last couple of days, I've created some repository that allows you to access the data, visualize the data. So specifically, I'm going to show you the Maxar Open Data. So if you go to my GitHub organization, the link is also in the video description below. You click the Maxar Open Data. So this is where I uh, um, retrieve all the Maxar data, the imagery for all the events. So on the you click the data set inside, you should see all the data for some major natural disasters. Maxar release those open data for anyone to use. During the past couple of weeks, some of those imagery that are widely used in Morocco earthquake here, and also Libya floods. This video, I'm showing how to utilize the data and then to do segmentation, extract buildings, something like that. So here, if you go to the take the GeoJSON file, so this one shows some of the imagery, all the types, right? So if you zoom in, you see mostly for one area is kind of small image, but I also provided the union GeoJSON again, Libya floods and underscore union. So this one mosaic all the images together as a visual image by catalog ID. So for the quiet same time, they merge together. So in that way, the file size is not too big. It's much easier to visualize on the web. If you want to download the data to your computer for analysis, then you can look at the CSV file. So this one here, the TSV, the tab delimited. These are all the images. Scroll down, it will show you the total number. Right now, this is 88 images. We have a header at the beginning, so 88. Scroll to the right. The last column shows you the link image. This is the visual RGB, but also have multispectral and chromatic. So if you want, you can click and go to any link text, go to, go up, and then download this one to complete. These are all the open data. You can use it to analysis. Specifically in this video, I'm going to use one image and showcase how we can use that to do. Besides the open data repository, I also created a native web app that allows anyone to visualize the data interactively. So the link is also in the description. Here you can just click, for example, Libya, right? And it's going to show you the footprint, the union geospatial that I showed you earlier. Then you can zoom into the location. Here, there are a couple ways you can get the imagery. So first, you can upper right here, you can click select the events. This one we're using the Libya floods September 20. And if you want to filter images by a specific date, you can change it. Yeah, if you want. Also, these are all the image catalog IDs available. So total we have 7 catalog IDs, but as I showed you earlier, it has 88 images. Mosaic them all together by catalog ID. So now we have 7. And select one of those, or you can just zoom to anywhere you like and then click your mouse on the map. It's automatically all the images that intersecting your mouse click location, like this one here. And you can click outside, it's going to select another one. Specifically, I'm going to just zoom in to this location near the coast area. And this is I think the city of Derna, Libya. So I uncheck the footprint, so clearly this is where the heavily flooded area near the coast. You can clearly see all the bridges were broken and also the flood area, many buildings washed away. If you want to compare, you can click the split map. This allows you to compare with Google satellites before the flooding, right? Highway was away by the flooding. Website, you see, they're all destroyed. We are going to utilize the post-event satellite imagery to do some segmentation so that you can potentially extract the building, see how many buildings were destroyed. So Again, you're welcome to export this one, and I'm going to download the. Actually, I already downloaded this. Just use that I provided. It's under the Open Data repository. At the beginning here on the home page, you click this link, take you to Google Drive. So I already provide the data for Libya and also Morocco. So I'm going to click Libya. It's going to show you the Derna building geospatial. They also I share 2 days ago, and those are by Google. But I convert the CSV to geo easily. I also provide the Derna sample. So this sample that we're going to use this tutorial. There's a big one. So if you click on the right here, this is a larger area, but it's going to see the memory allow to collapse. So the small one, if it's large GP, try on a large one. Okay, this is some of the data set you can utilize. And yeah, so next let's go to the get the notebook. You go to the segment geospatial documentation. Left side, click examples. Maxar open data. This is the notebook we are going to use to the segmentation. You can directly run the example collab. So just right click, open a new tab, then open this one on Google Web. First step is log into your email account. If you have not done so, log in. Then click the runtime, change runtime type. By default is CPU. Need to use CPU much faster. Click save. Upper right here, you can just click the connect to for you. Once it's connected, then we can start running the notebook. Here, I think when you open this, comment it out because it's not going to install the packages. So Control slash, we do remove the hashtag at the beginning and click one. It should install all the packages, all the dependencies, and we can start running the code example. One thing to keep in mind, recommended way is to always restart the kernel after you install the packages. Otherwise, sometimes you might run into errors. For this notebook, I have tested everything runs fine. If you don't restart the kernel, you will run into errors. So what you need to do is just clear the output, then runtime, restart runtime. Yes. You don't need to reinstall again. After you restart runtime, just click the button. It should import the libraries. First time it might take a couple seconds. Then it should be right here. If you click upper right here, click this one. It will the resources being utilized. 13 gigabyte of RAM and also 15 gigabyte of right now it's not being used. First, let's download the sample imagery from Google Drive. So this is the one that I showed you earlier. It's on Google Drive. So anyway, it's you can just follow the link in here. If you want, you can open this one in Google Drive. Take you to download this one if you want manually. And we're just going to provide the link and div map download file function. Download the image. Take seconds. Done. Once we have the imagery, then you can create a map and we can add the satellite, Google satellite based map and add the raster. So call the function add raster. Passing the imagery, the layer name, also add the layer manager. Layer manager is the one right here. We are using this on Google Colab, so it's a little bit laggy, but if you run it on a local computer, it's very smooth. This is basically just going to zoom in to the location slowly. And on the right here, the layer manager. So color doesn't look good because we're using the dark mode. But this is more like an issue with iPad widget. Something I can. Okay, so the imagery has been displayed. And the layer on and off. But you run it on locally. You do change the layer opacity. So it should turn the layer on and off. So here, the data layer with opacity. Reason for this is add raster function, local type server, not a server on and drive. Sometimes the communication might have some always. I keep running. Run again. Sometimes just wait for it to finish it to the and once you have the imagery, then we can start doing the segmentations. Some of the default segmentation parameters. And customize it if you want, but because it's a foundation model, the default segmentation parameters usually should be good. Okay, so now it's done. It's yeah. So now it works, right? So I can layer on and off. To be laggy, but you can also use the slider. Anyway, just play with it. And so what we want to do is to segment this imagery. And again, these are all the default parameters. Welcome to make adjustment. Doesn't work well for your image. Next step is to initialize uh, the the same model, the segment anything model. So I forgot to run the for block. And so when you are initializing the segment anything model, it's going to download the track point, this URL, because it's not found here under this current directory. And it's going to download it to this temporary directory. So you can think about this is the foundation model with all the weights for the model. And we're going to basically load the model into GPU. Then you can just use you can segment any image. So this is where it's going to be computational intensive. I'm going to use the GPU. Right here, right now, it's still not being used yet because it's still downloading. And this foundation model is 2.56 gigabytes, so it's pretty big. You need to have at least 16 gigabyte GPU to be able to do the segmentation. Right now, they're still downloading. Once it's done, then we're going to load the entire image into the GPU, and then we can do just the segmentation. So this is basically just 3 lines of code. Specify the parameters, initialize, and then do the segmentation. So the function is called generate. We'll be able to reuse it later. So let me come back to this. There's still no. As I said, if you have a GPU, you can try it on local computer. This is pretty smooth. Just a local type server and go tolerate issue. And once you finish initialization and downloading, then we can do the segmentation. And so the output can specify as a raster image. Also, you can specify the foreground whether to true or false. So the algorithm is going to automatically detect the background, not extract the object for the background. If you set to false, it's just going to segment everything. The result is going to cover the entire image. If you set foreground equal to true, then you're just going to extract the foreground object, and then the background will be 0. So basically, that way, you can focus on the object that you want to set. As you can see, now it's finished loading, and on the right, yeah, so it's finished initialization, and so you can see a slightly a big jump in here because of the 256 gigabyte GPU. The model has been loaded into. Then we can start doing the segmentation. Just run this line, segment general input data. Okay, you want to output. So this mask is just a grayscale. Basically, each object has a unique number associated with it. So basically, unique ID. Then it's by a grayscale. So 1 to whatever number of objects. Right now, you see 13.8 gigabyte. Pretty intensive. We're using a large area. Yeah, going to work because this free GPU enough for this example, but need a larger GPU on large image. Also, or you can subdivide the large image smaller tiles and segment one individually on workaround. But this just showing you the demo. It should work because I have tested before. everything was fine. RAM and also GPU. So GPU is close to the maximum allowed, but it will stay around 13.8 gigabyte GPU. Once it's done, then we save the result. It's a vector. Okay, so you see it's done. Then on the left side, you can refresh. Now you should see this mask.tip. This is output result of the segmentation. And you run this one, it will put the raster vector. Press again. Now you see the mask, the spread file, or you can save to GeoPackage or GeoJSON, whatever file name that you file format you use. Once we convert to the vector, now we can actually visualize the results. I think by default is the binary R, so basically just the grayscale imagery. I'm showing here binary R first. This color map you can use any map, probably color map. So by default it looks like this from dark color. So this last area, this is the background. Not actually not being extracted, is 0 background. Then increase from 1 all the way to the maximum number of objects. The larger the area, so the color is ranked by the size of the area. So the larger the object, the brighter the color. And clearly, some of the last one here, so those are not belong to buildings. They probably remove the set. Make the color map, for example, cool one, by any color map, any color palette supported by Matplotlib. Change it here. Now this one, also the earlier one, GST, right? Any color map you want. This is basically a random color. The segment NC model doesn't know label, doesn't know it's building, water, or object segmented automatically. Then you can also overlay the color, the imagery annotation top of the original image. Basically, have the satellite imagery in the background and also label the mask top of the satellite image, blending into by control or pasting. This way, nicer because you have the imagery background. And that now we can even maybe run an image comparison like this. Image comparison is a tool that allows you to have either image on the left, or image on the right, the label left, and label on the right. This way you can use the slider to swipe through the imagery and here result. Take a look. Please not take too long. Basically converting the imagery and then reading the imagery and then generate the slider. Okay. So once you finish, I will show you how to. Also, there's another one here, overlay image. This one won't work on Google Colab, so you can skip it. But if you run it on local Jupyter Labs, fine. Besides using the image comparison, you also be able to display the images on interactive map. And lastly, you can also okay, it's done. Take a look at the slider. Clearly, use the slider to swipe through object, overlay on top of this. Also, upper left corner, upper right corner, label being. This give you a nice, easy to listen to utilize. Again, I'm going to skip this one because it doesn't work. Next, we can display the result top of the image. Right, so here it might be a little bit laggy, but all the data there have been here, including the binary mask. The station. It might take time to load up. It's just a Google. To work on a local computer is besides raster data, you can also load the vector data. Earlier we have converted the raster in vector. So now we have a spread file here. Just use the add vector function, load the vector data on the map and the data layer. still loading, but it's come out eventually. What you can do is just wait until it's done, and you should see something like a screenshot of what it looks like. You can have the original imagery that you use for the segmentation, have the binary mask. You also have the annotation, random color, vector data. And with the vector data, you can clearly see here it's not going to be perfect. See this as the background, fine, but there are also some water, some flat area, and also some vegetation that are also not uh, being segmented as an object, but those are not. You're trying to access the building damage caused by the floods. Then you need to have some pre-existing buildings, the one that I showed here, so you can download from the Google Drive. Then you can use this post-event imagery to segmentation and get some initial results like this. Of course, you need to do some post, remove the, for example, the water and others, doesn't get confused. This last area, you can set a filter to our last area. Okay, take a look. So now it has been done. It will all here to collect, but at least you can see the data layer. You should be able to turn it on off if your computer. Right now, is some application is back here, but this is see what it looks like. So now automatically segment all the objects, all the buildings, trees, and others. Then you can do some post processing, remove other objects. At least you can see the buildings. Those should like not perfect because this is quite heavy, so it's a segment master into vector. But you can also simplify the vector if you want by specifying this, or when you go to the come back to here, master the vectors. This one allows you to specify the tolerance, automatically simplify vector data. Reason why it's pretty slow because you have a if you talked about vortices, file is pretty, but you also have the raster image, binary mask. You're also welcome to try out other segmentation methods. You can also input prompts, right? So you can load the imagery and then you can select interactively. Imagine that you have the load imagery of the Maxar open data and just click your mouse on the check some of the buildings. Hopefully it will check other buildings. I don't have time to show you in this tutorial. Try it out. You can also use text prompt, right? So load the imagery and then display the active graphical user interface. Then just type maybe buildings or anything else that you extract. But the result might not look as good as this automatic segmentation. This one usually does pretty well, but it doesn't have the label. But if you have the input prompts, text prompt, you know what you are trying to classify. That way you know the label. So like training the data, asking them to classify the object. But you can also use this one just to get fishing, also assign the label. Hopefully in the future video, show you how to maybe do the segmentation on large imagery and maybe also utilize some other deep learning model like specifically they can extract things, other features if you stay tuned. After I finish the implementation, we integrate it in different package. Easier for you to segment any raster image. Now a lot of like preparation for. Okay, so that's all for this video. I hope you find it useful. I will see you in the next one. Bye bye.